A square loop of wire with small resistance is moved with a constant speed from field-free region into region of the uniform B field. Okay, so here we have B field into the page, then back into the field-free region to the right. Okay, so basically it will just stop here. Okay, the self-inductance of the loop is negligible, so we have to understand what's happening while it's entering the field, inside the field, and leaving the field. Okay, I will not look at the questions whether true or false, but I would rather explain what will happen in entire journey of this loop. Okay, so you have to bear with me because it's slightly a bit confusing on all, so you have to pay attention carefully so that to understand what will happen with the field. Now, the main thing is here is the Lenz's law. If you try to revise the Lenz's law, it says that the direction of the induced EMF drives the current around the wire loop to always oppose the change in magnetic flux that causes EMF. So basically, the current will flow in the loop in such a way that it will always oppose the change in the magnetic field. Okay, and in other words, so first of all, let's try to understand what will happen in the field when what will happen when the loop will try to enter into the field. Okay, so when entering the field, the coil experiences the direction of the force and direction of the current. Now, when it starts entering the field, okay, it's not fully entered, but it started entering. When it started entering into the field, the direction of the current should flow in such a way that it will oppose the magnetic field. Okay, so in other words, I would say that while entering the field, the loop tried to oppose the magnetic field to the B2. Okay, so in order to oppose to the B2, what should be the magnetic field? The magnetic field should be basically out of the page. Okay, B should be out of the page so that it will oppose the magnetic field to the B2. So I call this one B1. B1 should be opposite to B2. If the B1 will be the opposite to B2, then what will be the direction of the current in the loop? So you have to use your right hand rule, and therefore we can see that the current will flow counterclockwise while entering the field. Okay, now if the current is flowing counterclockwise, then what will be the direction of the force? Now the force generated opposes the cause. Okay, or in other words, I would say that the coil experiences a force towards the left which tries it to stop entering the field. Okay, so that means the coil will start to oppose entering the field, therefore the direction of the force will be here towards the left, so I call it FB. Okay, in other words, I try to relate this phenomenon to the life. For instance, when there is a bad habit, you don't want to do that bad habit, so you try to oppose to do bad habits. But however, some people, once they started doing that bad habits, it will be difficult for them to leave that bad habits. Okay, so that means the magnetic force will try to point to the left so that it will try to stop the loop entering into the B2 field. Okay, so far we understood that direction of the current will flow counterclockwise when it tries to enter the field, and also the magnetic field will be opposite or to the left, which will try to stop the loop entering the magnetic field B2. Okay, now what will happen when the loop is inside the field? When the loop is inside the field, there is a magnetic flux. There is no change in magnetic flux. Okay, it's constant. If it's constant, it's not changing, therefore EMF will be 0 in the loop. Okay, there's no change in the magnetic flux, therefore EMF is 0. Now, what will happen when the loop is trying to leave the magnetic field? Okay, so that case means this is the third case, right? This is the first case, this is the second case, this is the third case. What will happen with the loop when it's trying to leave the magnetic field? Now, when its loop is moving to the right, okay, with a constant velocity, and as it starts leaving the B2 field, the magnetic flux will become less and less, right? Because the loop is leaving the magnetic field B2. In that case, the current will flow in such a way that they don't want to reduce the B2. Okay, if you don't want to reduce the B2, then how the current should flow? So in order to stop the magnetic field becoming less and less, the B1 will be into the page. Okay, that means B1, if it wants to make keep the magnetic field, doesn't want to change the field, or opposes becoming less and less, it will have magnetic field into the page, and therefore the current will try to flow clockwise. Okay, so here the current will be clockwise. Okay, so if the current flows the clockwise, then as I said, when someone is entered into the bad habit, it will be difficult for him or for her to leave that bad habit, right? So what you think that what should be the direction of the force in this case? It will basically will try to stop to leaving this loop from the field. Okay, therefore the magnetic field magnetic force will be to the left. Okay, there is another way of finding it. First of all, you have to use a right hand rule where the direction of current is pointing upwards. If you take this point upwards, magnetic field B2 is into the page, so therefore the B will be pointing towards the left. Or in other words, it try to stop the loop leaving the magnetic field B2. Okay, so I think that's it. So far so good. I think